Hi guys, welcome to this Docker tutorial. In the previous video of this tutorial, we discussed about a problem statement where we tried to understand how we can create a custom image based on our requirement. So if you haven't watched that video, please go to this playlist and you can look for the video number 10 where we have discussed these things. I would highly recommend to go through this video because without watching this video it would be little difficult to understand the further things what we are going to discuss today. So let's start the video that we are going to discuss today. So today's topic is Docker image layers. So we are going to talk about image layers in detail. Okay, so let me explain you what is layer in terms of Docker image. So let me open the whiteboard. We learned about Docker file where we write few instructions and those instructions are getting executed and building the image. So in Docker file we saw, right, we have some instruction started with from, or we also saw regarding copy and other instructions as well. Each line of instruction creates a layer. Okay, so let's understand how it works. So let's say if we talk about Ubuntu. So this Ubuntu, this is the official image of the Ubuntu, and there would be a Docker file created, and from that Docker file we will have image built, and that image is available in the Docker Hub repository. So let's suppose there would be one Docker file and there must be number of instructions mentioned inside that Docker file. So while creating image, each instructions act as a layer. So how it works, let's say if it has few layers, let's suppose it has 3 layers, right? So it will create layer 1 for one instructions, we can mention it as L1, then it would be layer 2, and then it is layer 3. Now this is the final image. This is the final image which has having 3 layers. Okay, it is having 3 layers. Now from Ubuntu we wanted to create our own image. So we saw this Ubuntu has 3 layers, and now we want to create our own image and we will add more instructions. So let's say we are going to add instructions for copy and run as well. So the first instruction would be from Ubuntu latest that we have seen in Docker file in the previous video, and then we have copy and run. So it means this Docker file has 3 instructions, and the first instruction is the image, right? And that instruction itself contains 3 layers. So now when you build an image from this file, how it works, these 3 layers which is required for Ubuntu to to bring it here, so these layers will be L1, L2 and L3. So this is the layers which are mentioned in Ubuntu official image. Tag with latest. Now because we are trying to create our own Ubuntu image, maybe we can make it as a custom Ubuntu. So in that case it will have 2 more layers. Okay, so it will be like, you can say L1 dash, then L2 dash. So how it works, when we go through the Docker file, the first line or first instruction tells that need to execute this statement. So to execute this instruction, it already find that there are layers available in your system. Okay, so that's why it will refer them and it will not go to rebuild those images, I mean those layers. It will build only those layers which are not available in the system. So that's why I have marked it as L1 dash and L2 dash. Okay, so in this way it is going to save the memory as well. Let me take another example. Let's say we have Ubuntu some 20 version. Let's say this is the version. Okay, this is the tag. So there are two tags. So first I pull Ubuntu with this version tag, and this, suppose this is having three layers. Okay, now when you pull Ubuntu latest, so if there is no concept of caching in Docker, what would have happened for Ubuntu latest? If I talk about this one here, for Ubuntu latest, again it will create layers for them, L1, L2, L3, and then maybe on top of that it will create L4. So here you can see that it is occupying the redundant space. Both the images, right, both the layers till here are same. So that's why if you are going to rewrite the same layers again and again, it means you are going to utilize or consuming your storage unnecessarily. So that's why there is a concept of caching in Docker, where it always tries to find out the layers available in the system. If it is not available, then it goes and download it from the registry or repository, you can say. So now in this case, because Ubuntu version of 20 with this tag, right, so definitely this latest is created on top of it. So in that case, this latest version will have everything, and then on top of that there would be a few improvements. Okay, so that's why when you do Docker pull this Ubuntu latest after doing Docker this version, what it does, it verifies whether these three layers are existing in the system or not. If these three layers are existing in the system, it says already exist, and then it moves to download for the new version. Okay, we will see these things in practical in few moments. So now you can see that if we are able to remove this redundancy, in that case what we are doing, we are also saving the space. Okay, each layer, if we talk about layer, right, so each layer has its own SHA 256 digest value. Each layer has its own SHA 256 digest value, which is always unique. If you use this layer n number of times in any image, the digest for that layer would be always same. Okay, so and once this image is created, let's say this image is created. Now if we see, this image is created after this image will be created, and this is right Ubuntu latest. I'm tagging it latest. We will discuss about the image tagging in the next video. So there we will discuss about this image tagging in detail. So till now you just need to understand we are using this latest tag here, and once this image is created, then we will have a image ID, and based on this image ID, based on this image, there will be a digest to SHA 256 digest that will be always same for this image. We will see these things in practical. Okay, so that is what I wanted to discuss before getting into the things practically. So I hope it's clear. Let me conclude this. Images consist of layers. So if you have mentioned instructions in your Docker file, So each instructions are layers. Each instruction will create a layer. Layers will be created for all the instructions, but there is one catch. Those instructions which are not affecting the file system, those are intermediate actions, right? Intermediate instructions. Those instructions which are intermediate, they don't consume any space, and others which are affecting the file system will consume some space. Okay, so for example, if we are using label, we have one instruction called label. This is related to metadata. This is nowhere going to impact the image. It is just holding the information about the image. That's why it is nowhere going to consume any space on the system. So that's why it won't create any layer when you build the image. Okay, so I hope it's clear. Those instructions which are going to impact or do some modification in the file system, they will create layers, and those instructions which are part of metadata, they will not create any layers. Okay, I hope it's clear so far. So let's get into the command line. Okay, so let's take Ubuntu for our practical. We are going to use the Ubuntu official image. So let's first explore the Ubuntu official image. This is the official Ubuntu image page. We should go under tags. Under tags, we will find all the tags for this Ubuntu image. So we are mostly using the latest image. So let's click on that. So when we come to this page, we can find out like how many layers are created for this image. So you can see it's mentioned layer 6. So there are 6 layers which has been used while creating the image, right? So you can see these are the instruction, and for each instruction there is layers, right? So those layers, right, which are modifying the metadata, they are not consuming any space, 0 bytes, right? And this is the add file. This is something which is going to change the file system. That's why it's consuming some space. So let's explore this from command line. I'm going to pull docker. I'm going to pull Ubuntu official image. So docker pull Ubuntu latest. Okay, so you can see that the file system layer is not available in my system. That's why it was downloading that layer. We will discuss in detail about the importance of digest in upcoming videos. Now if you want to see the number of layers, right, so we can go here, docker, and we can mention the image name. So you can see here we have 6 layers, right? So we have 6 layers, and the same 6 layers we found here as well, Ubuntu latest. So that is why I said like we can find out the number of layers through this command. Okay, docker image history, and we can specify the image name. I haven't provided the tag, that's why it's by default latest. If you have image with a different tag, you must have to provide the tag as well if you want to see the image history. Let's get into the docker file what we had created in the previous video. So this is the docker file what we used in the previous video to solve the problem statement. So now here you can see I have done some modification. I have removed the installation of JDK and curl because that was taking some time. So if we see how many instructions are here, so we have 1 2 3 4 5 and 6. There are 6 instructions in this docker file, I'm excluding this CMD because we have already discussed like this will be executed when you start or run the container from this image. Okay, so let's create an image from this Docker file and let's see what's happening. For you to understand, we have already pulled the Ubuntu latest version, and now we are going to take Ubuntu latest as a base. Okay, that's a base image. Now if you see the Docker file, we are taking Ubuntu latest as a base image. So here when I try to create an image from this base image, it means that information related to the base image is already available in my system. So that's why it should not download those layers which belongs to Ubuntu latest image, and it should only build layers for the new instructions which is mentioned in this Docker file. So let's try that. So I have mentioned here the image name and we have created our own tag. Instead of changing the image name itself, we are just modifying the tag to identify the new changes, right? And here we can mention the -f to specify the file. If you guys you are not understanding what is this -f and why we are using this, I will suggest to watch my another video from the playlist where we have discussed about this in detail. Okay, and then we mention the current location. Okay, let's explore this. The first instruction from, which is considering Ubuntu as a base, so that's why it is not doing anything, because that's already available in the system in the cached version. Now it's executing this statement and then copy instruction and then run, and then after another run. So we have total 5 instructions here. If we go to files here, we have 1, 2, 3, 4 and 5. So this is not considered as an instruction because this is a metadata. Okay, so let's go and see in the command line. Here you can see it's exporting the layers. It's exporting the layers, and after exporting it has assigned one digest for that. So now let's explore this this image in detail. Okay, before that we should do docker image ls. So we have two images, one tagged with custom, another is latest. So custom is the one we have created, right? So now we are going to inspect both of them one by one. So let's first inspect the Ubuntu official one. So docker inspect, we can also mention docker image inspect or docker image inspect Ubuntu. Okay, so by default it takes the latest, and if you, okay, so this is the output of this command, docker image Ubuntu inspect Ubuntu. We haven't mentioned the tag, it took latest as a by default. And if you come here, this is the ID, and if you come down here, you can see one layer, right? So this is the only layer which is consuming a space, right? So that is what we saw in the history as well. So let's copy this and let's put inside this online text comparator. Okay, copied. Now we are going to open the another one, Ubuntu dev, sorry, it's custom tag, custom. So now here you can see, if you scroll down at the bottom, right, so you can see here we have the different layers. So how many layers are there? 1, 2, 3, 4 and 5. So there are 5 layers, and each layer has its digest. That's what I talked, right? Each layer has its own SHA digest. Okay, so the left hand side we have a layer information from the Ubuntu official latest tag, and on the right hand side we have layers information from the Ubuntu custom tag, that what we have created from a custom Docker file. So now you can see the first layer is same in both these sides, so which says that this is the base layer, right? And this layer is created while creating the official image of the Ubuntu, and other layers are created on top of that. So that's what we discussed, like it is a kind of a stack where we have one layer already available, and on top of that we are creating another layers. So if we see here, as I said, right, so this layer is already available from Ubuntu latest, and then on top of it we have created another four layers, and this makes Ubuntu custom. So this makes custom image, and this is the digest for this Ubuntu official image. Guys, I hope it is easy to understand. I have tried my level best to make it simple to understand, right? So now, so far what we have done, we have pulled a Ubuntu official image, then we have created a custom image, and we tried to understand how many layers are getting created, because we learned if each instruction in the Docker file creates one layer. Okay, and there are few exceptions regarding metadata where layers will not be created, and we also learned how to inspect a image. Now if, and we also learned about to check the Docker history. If you want to know the layers history, you can do Docker image history, and you can mention the, so far here it's saying that image is missing because it's not created in our system. Here till here we have a from, and then after the command, right, what we have executed. So if you are seeing, if you want to see them in detail, so like you can change the command custom, after that you mention no trunk, so you can see those things in expanded form. Good. Okay, so now one last thing I want to mention here is, if you do some change in this file, so in that case how these layers will behave. So let me explain you one thing here. Let's say we have 5 layers, L1, L2, L3 and L4. If you are doing any change, and we are considering this as a base, so if you are doing any change in L2, if you are doing any change in L2, so the upper layers will be rebuilt because you have modified the L2. If you are modifying L4, if you modify L4, if you modify this L4, then others will not modify, so this will remain same. These 3 layers will remain same. There will be no change, there will be no rebuilding process. Only this layer will be rebuilt. So let's see these things in practical. So as of now you can see I have done these things. So what if I remove, or what if I do some change? Instead of this ps-ef, we can just modify something, like we can say, we can mention also like this ps-ef grep root, something like that. I have done some change in this file at line number 7. So as per my this modification, the layers before this statement or this instruction would remain same, and the layers after that will be rebuilt. So as of now there is no instructions after this, so let me write some instruction. Okay, so I have added one instruction to create a directory with name my test. Okay, so now we will see changes after this. Okay, and let's do one more. Okay, let's see this one first. So if I save this and come to this command prompt, and here if I try to create image build -t Ubuntu, and then let me make it like custom one, and then we will mention the file name and the directory. Okay, so that's what I wanted to show you. See here, this is the first one, right? This is the first instruction which is not going to be built because it's a base image, it's already there. Now the other statements, right, the other layers, this was the layer, it is not going to execute them, it is just fetching it from the cache, right? You can see this, it's saying that cached, so it is saving your computation as well. Okay, because these three instructions were already executed while building the image. So now this time it will pick only those images to execute, those are modified. So because we have done changes in fifth instructions and sixth instructions, that's why those are getting executed while building the image. Okay, so now let's see how it is going to behave if I modify something in between. So you can see, right, I have modified this second instruction. It means if I have modified second instructions, it is going to impact the instructions which are coming after that. It means any instructions coming after that will be rebuilt. So let's see that how it is behaving here. So if I try to rebuild again with some different tag, let me make it as a custom 2. So hit enter. Oh, sorry, we need to change here as well, or we need to, here we have mentioned Java, right? So let me just change it. So I have corrected this file. Now let's rerun again. Okay, so let me remove this. Okay, good. So I wanted to show you, right, I have modified the second instruction. Okay, so why it is cached here? Because when I executed first time, right, even though I did mistake, so let me show you here. So here if you see, the first one is cached, the first instruction is cached, and from there onward all instructions are getting executed. Even though my Docker file was having some error while mentioning the directory name, second instructions and third instructions were executed successfully. Okay, so now if we go down, so after that whenever it was executing, it was saying that cached, right? And here as well you can see it is cached, second one is cached, and after that all the layers is being modified. So let me retry once again because I have done lots of changes here. So in this time I'm going to do a very little change. Instead of this building, I will change the text of this value, hello docker, and just save this and try to build an image again. So what would be the expectation? So the expectation is, because we have modified the second instruction, all the instructions coming after this should be rebuilt. Layers will be rebuilt, right? So now let's see that. Okay, so you can see, right, only the first one is cached. Apart from that, other layers are executed and layers are built again. That's all for this video. If you really liked it, please hit the like button and please don't forget to subscribe my channel. Thank you very much for watching my video.